So, when talking about the strongest thunderstorms and ones that generally produce tornadoes or thunderstorms that produce tornadoes, we're generally talking about supercell thunderstorms. Tornadoes can happen in non-supercell thunderstorms, and supercell thunderstorms can not have tornadoes, but these are generally the strongest, most severe thunderstorms, and it often will create tornadoes. And the reason they do this is because they have an internal rotation to them. And you can see this is kind of like a setup for a standard frontal system. It's not, but you've got a gust front here, you've got an updraft setup, and basically what's happening is you've got a warm area of air that's got an updraft in it, so it's constantly feeding warm, moist air from the surface into the center of the storm, keeping it energized. And the downdrafts, again, because of that rotation, are shifted out of the way of it, and it's allowing that moist air to be moved up into the air, providing energy to the storm, and the downdrafts are getting out of the way. And you've got two of them, the forefront downdraft and the rear downdraft. Now, why this creates a tornado, and usually a tornado will be at that center of rotation, right about here, because you've got a storm rotating in this direction. Supercells can rotate the opposite direction, but we're not going to talk about that for the moment. We're going to just go with the standard model of this sort of counterclockwise rotation, pushing everything out of the way. And because of that, you've got multiple forms of complex rotation. So you've got a twist that way, and that rotation is actually speeding up as the storm grows and stretches, in the same way a figure skater going from a sitting spin to a standing spin will speed up. They're conserving their angular momentum, so they'll speed up. So by stretching out the storm as it goes from a shallow storm to a storm that takes up the entire troposphere and even may have an overshooting top, it gets bigger and bigger, and it speeds up, and it maximizes that mesocyclone, or that rotation happening within the supercell. And so that's one form of rotation. There are others. So you've got that vertical rotation, you've got different speeds moving in different directions at different heights, and as you get higher in the atmosphere, generally the winds are moving faster. So you've got rotation in the vertical, and you've got wind shear causing overturning, as you can see here. So basically, if you've got that twisting rotation and speeding up, it's creating a column of air at the surface that's then being forced up and rotating even more, which may seem a little odd, but if you think about it in terms of a slinky, think of a slinky stretched out, and basically the way the coils are moving is the way the wind is moving, and all of a sudden you're twisting and stretching it, and the center of it gets pushed up as it falls into that updraft. It twists it, and you get rotation. And if the rotation lines up with the rotation of the supercell, it's going to combine to maximize that rotation, and then you can get a tornado forming from that. So basically, if you think about it, the supercell is rotating like this, like my cursor, and as the storm grows and stretches, it's speeding up quite a bit, and then because you've got higher winds at the top, it's overturning, and then it hits that updraft and gets twisted into the vertical, creating a tornado.